Number 5b is another problem where we have to use a double angle identity in order to establish the identity. So this one here, we've got a sine x minus cosine 2x, and then we have this on the right-hand side. Now we have the different formulas I have listed here for cosine 2x. So we have these different ones to choose from. And we notice in here that there is a sine in here already. What I want to do is I want to pick the identity to where I have the best chance of being able to simplify this together, and I'll have everything all sine or all cosine. I want all the trig functions to be of the same kind. So if I take a look at the first one, cosine squared minus sine squared means I'm going to have a sine with a cosine squared. That's not going to be any like terms, so I don't want to use that one. The second one is 2 cosine squared minus 1. If I have 2 cosine squared minus 1 plus a sine, again, I have sines and cosines I'm not going to be able to do anything with. The last one, however, I have 2 sine squared x, and I have a sine here also. So because I have a sine and a sine squared, that would allow me to be able to do some factoring. We notice that on the right-hand side that we actually have everything all in terms of sine, which means the left-hand side will need to have everything all in terms of sine. So what I'm going to do here is I'm going to put in the identity, this one down below, 1 minus 2 sine squared. Now keep in mind that there's a minus sign here, so you got to be careful about that because you want to put in this in place of cosine 2x. So the minus sign still needs to remain there. I'm still going to leave this the same on the right-hand side here. So I'm not going to do anything with this just yet. Just going to go ahead and leave that alone as is. So all I did was I took out the cosine 2x, replaced it with 1 minus 2 sine squared. The minus sign is now going to be distributed into each thing. So I'm going to do minus 1, then I have plus 2 sine squared here. Okay, so distribute the minus sign, and that changes both these signs here. And so now I have this again on the right-hand side. I'm not going to do anything with that as is. Okay, so just leave it as the plus 1 over there. I can change the order. So I'll switch the order around here. 2 sine squared plus sine x minus 1. Just writing it with highest to lowest power. So I have a square here, a power of 1, and then power of 0. There's no sign on the end there. And then we have this here. Okay, and now we just need to factor the left-hand side, or if we want, we could expand the right-hand side, and both of these should be equal. I'll just go ahead and factor it. So we should get this, and then we'll have both sides equal. Let's just check to make sure that that would work. Okay, in order to get the 2 sine, I would need a 2 sine x here and a sine x. On the end, there's a 1. So there's only 2 factors of 1 that I could use there for that one. And then I need to play around with the signs. So 2 sine squared, I want to get a positive sign. So I'm going to put a plus here and minus there. That way I get a 2 sine minus sign, gives me a plus sign there. And then minus 1 plus 1 gives me minus 1. That tells me that now both sides are now equal to each other. And so that means that we've shown that this is an identity. So what we could have also done on this problem is we could have actually just expanded this right away from the beginning and then just have the expanded version all the way down. And then once we get this here, then we can stop. So that would avoid doing any kind of factoring. So that is another way of doing it. So in the answer key, that's how it was done there, was expanding the right-hand side first, but just showing you, you could just leave it like this all the way through and then just get the factored answer. So either both factored answers or both expanded answers, both of those would be considered correct as long as you show that both sides are equal. You have verified the identity.